In any big company that has any kind of software powering it, you can be 100% sure that that software is going to be tested on some level. There are different testing levels like unit testing, integration testing, system testing. We're going to talk about all of these in different videos. So specifically, this video is going to be dedicated to unit testing, and it's the first kind of testing that you really start learning because it's on the most basic level, just a single unit, and you want to test whatever logic that has. So first we're going to go over a little bit of an introduction, and then I have some examples here that we're going to build unit tests for, and I'm just going to make sure you understand how to use XUnit, some best practices, and how unit testing can highlight some of the issues that you have in your code, okay? So let's just quickly go over some of the more frequently asked questions sort of thing. So why should I test my code, right? I've written my code, no problem. I know it works, right? So I don't know if you've ever done it, like you've written a piece of functionality and then later it broke and then you're like, I thought this worked, right? And then you go and test it again, especially in web development when you got the UI and you're interacting with it. So when done right, testing your code will save you time. I know it looks like, oh man, I have to write more code. That's gonna take time. But no, at the end, it will save you time because you're gonna know stuff isn't gonna break, right? Reliability and confidence. If you may be not struggling with this if you've never had a job and you've never had to publish anything to production. Once you have a multi-million company relying on the software you ship, that kind of becomes a thing that burdens on you. So once you have those tests behind you, basically telling you like, yeah, it's okay to go, you're you feel a little bit easier. But if you're just publishing blindly, it's not going to be a good time, especially if it breaks later on. You're going to be like, oh man. So anyway, improve the code base quality. Again, it may not be super apparent how, but testable code generally just means better code quality because you will need to apply separation of concerns, basically dependency inversion, higher abstraction levels, and I mean testing will just kind of like highlight those features for you. And next thing, safety for future developers, right? You work on an application, you leave the company, next guy comes in. If you don't have any unit tests, poor guy, right? That's oh yeah, you don't want to be that guy, right? So same as you don't want to be that guy who comes into a big code base with no unit tests, doesn't know what's going on, and so easy to make mistakes. Don't leave that space for any other developer. It's not fun. And also documentation. So sometimes you can figure out how the application works through unit tests if they're well written. But otherwise, I think using it as documentation can be quite tough, especially if you have a big testing suite. It's pretty much like an application on its own. Let's go ahead and kind of talk about which testing framework do you want. And by the way, this README files in this repository, it's everything in the description and a little more a link there that I put for you. You can click on it. But yeah, we have pretty much a choice of 3. I think MS Test has a version 2 out. I never used MS Test, never have I used MS Test version 2. I heard it's slow. I know it's mature though. I think NUnit's mature as well, and it has many features, and it's fast. So for me, it's pretty much XUnit and NUnit are fast. NUnit is just more mature. XUnit is just kind of like trying to be the future way, even though NUnit's more like industry standard sort of thing. MS Test, just because it's slow, that's kind of already, we're just going to throw it out of the window, right? So the real choice is between XUnit and NUnit. If you don't know either of them, like you just don't know, you never tried, or you don't know which one to pick, just pick XUnit, right? Nothing wrong with that. Most of the time, you will just be all right? You pick XUnit, you write your tests, and you shuffle along, right? Everything is fine and dandy. Sometimes, though, there can be situations where XUnit just doesn't give you that fine-grained control as NUnit does. So sometimes you will need to port back, and it's very easy to transfer your test code base from XUnit to NUnit. It'll be just like renaming attributes and stuff like that, maybe some initialization code, but it's generally a very easy job to do. So I wouldn't see this as like a very strong marriage sort of thing. So generally just pick XUnit, otherwise NUnit can give you a little bit, because it has more features depending on what actually you're looking for. But again, I'm just gonna say you should be able to just do everything with XUnit. Okay, let's go ahead and figure out a little bit like what to test, right? So this is gonna come back to this point where why should I test my code, right? If I write some code, I know it works, right? Well, why do I need to test? Well, there's going to be some benefits, right? Okay. What do I actually test? The easiest situation that you can be in, you find something breaking, you don't want to see it break again, write a unit test for it. You're good. The second bit is kind of like you haven't seen anything break yet, but what do you test, right? So you're going to have some features in your applications. So I've drawn out a couple applications here, and hopefully you can recognize which one is more valuable. If this feature breaks, like that's going to be bad. You're going to hear about it basically, right? But yeah, banking app, display about page, and money transfer, right? If somebody's not going to be able to transfer their money, that's going to be like instant response. Somebody's going to be like phoning, yo, I cannot send money to my mom. Like, what are you going to do about it, right? If somebody can't display the about page, you as a business might never find out, because nobody cares about the about page, right? Nobody's going to waste their time phoning you about it. So it's not really that big of a problem. All right. So in that situation, you want to make sure that the core functionality, like money transfer, we got to make sure that that works. So any components relating to that, test it, right? About page, and if you got time, write the test, right? Facebook, being able to create a post or receive group notifications, right? If there is no thing to receive notifications about, like why would you worry about testing your notifications and not testing, making sure that posts can be created so you can receive notifications about them, right? So again, I'm not saying don't test both. I'm saying sometimes there are features that clearly stand out that will be easier to pick, right? Okay, this thing needs to be tested, otherwise our app is not even gonna work. Okay, same with YouTube, playing videos or displaying comments, right? On some videos you even have comments just blatantly disabled, so that's clearly not like a detrimental thing. Playing the video is the more important thing. Online shopping, right? Clearly two important things like updating your stock or adding cards to the product. If you can add a card to the product, you can check out where your stock doesn't update after somebody makes a purchase. So you may oversell at some point, and then you're gonna see orders keep coming in when you don't have the stock, and at that point you can return the money. But if nobody's able to buy anything, you know, you're gonna be in a bit of a trouble, like you're not earning money. So basically what I'm trying to say is, you know, can you put a cost on it? Can you really say how much money something is gonna cost if it breaks? And if you can, good, it should be tested. So hopefully this gives you a bit of a sense of how to put value behind your code, that this thing isn't just abstract, it's actually making money. It is important that it works, okay? So when you have enough tests, this is one of those things where it's kind of like refactoring, you know, be it the coder's will or like an artist, they can just keep painting the same painting, making sure every little thing and cranny is perfect and shiny and whatever. That's not the way the real world works. So in short, when you're confident, again, there's gonna come back to this point where when you're shipping when you're shipping production code into production that you've written, and you kind of want to, like, you know, make sure the business doesn't fall over because of that, or doesn't crash and cause bad reputation. You know, you want to test as much as you want, but the point of test is it's gonna make you comfortable. It should make you comfortable, it should give you confidence. But there's also this time balance where you could probably give 100% coverage, but it's probably not that important, where if you're a growing company, you need to be giving out more features to your clients or the business side so they can do more business. With this, I would say, as you're going to be a junior developer or earlier on in your developer life, you just want to see how much, just test as much as you want, right? At one point, you're just going to get bored and you go, well, yeah, okay. And then you're going to ship something. So chances are, if you have code reviewers that are going to point out, why is this not tested? chance if you have none, you're going to go into production, something breaks, take a note, find out what has caused it exactly, and then in the future, you will be able to look out, all right, am I testing for this specific thing that broke, okay? Be it a null, am I always checking for nulls in my tests? You know, that kind of thing. So, some of you have raised the concern of communicating to the boss, the wider business, the importance of tests because it takes time. The important thing to realize here is that when you are supplying a feature, right? Let's say we want to add discounts to our shop. You don't go to the business and say, right, we can add discounts to it, but you know, we can make it on a week if we don't write any tests and we don't write any documentation and all of that stuff. And we basically, I'll just blindly write the code and ship it. And I mean, it might not work 1 week. And they're going to say, what do you mean it might not work? Are you a bad programmer? It's like, no, I'm a good programmer. I'm still okay. 1 week we'll just ship it, right? So don't do that. If you need 2 weeks to build the thing, and building the thing means test it, take it through QA, staging, other processes, right? So the time that you estimate is not just the development time. You as a programmer, you do those other things that are important, like, and the stuff that I mentioned is sometimes that gets neglected is like writing documentation, taking the time to pause and write useful commit messages, or being able to segment your changes into commit messages that can be traced in case in the future somebody makes a mistake, and then they go like they will need to trace back and be like, all right, why is this like this? And they see right the explanation in the commit message. That happens more often than you think. And admin work, right? How much time you spent on this? It just basically make your business analyst happy as well, right? So I'm just underlining 2 things to really be mindful of, that you are the professional and that you know better and that you are going to tell how long it takes, right? If your boss is a good programmer, he will understand. If your boss is not a programmer, you can take the analogy of a doctor, right? You don't go to the doctor and you tell him, oh, what do you mean an operation in 8 hours? No, I want it in 4. I want a 4-hour operation, right? That's what you want. Yeah, he will take it out, but not like sue you back up or whatever. Like that's stupid, right? So, and the second thing, all programmers suck at estimates. So when you're gonna say 2 weeks, you might end up going for 2 weeks, and then you're still not gonna have time for tests where you thought you were adding an extra week to write those tests. But we all suck at estimating, so just add the padding. And if you are still running out of time to write the tests, you want to be coming back to your business before the deadline. So 3 days before the deadline, when you realize you don't have enough time, that's when you come in the morning stand-up if you're doing agile. That's when you come and you tell them, I'm going to need more time. This is going to be delayed. Here are the reasons. And if somebody says, skip the tests, you don't skip the tests. It's what's going to help you to make sure your system works long time. Okay. So this is kind of like a general broader overview of testing, why it's important, what to test, knowing when to stop, and basically relaying it to the business. So let's take a look at some of the examples that I've set up here. They are more or less close to real things that you would implement, although most of these solutions will require mocking, and this is part of those things that you can use testing to figure out what's basically wrong in your code base. So let's take a look at it. We'll write the test first, and then we are going to talk a little bit about it, right? Not property hashing. First, we're going to take a look at a to-do list. I've already got the project set up, and source code is available. So go and grab it and you can follow along. Here, what I'm going to do is I'm just going to go ahead and create to-do list tests, right? And we're going to be writing tests for something that already exists, right? So this is not test-driven development. And here what I'm going to primarily do is I'm going to try to highlight 2 ways of thinking about tests. And you can pick which one you like more, okay? And create a public void. And let's go ahead and test this add function here, okay? We're going to say that add saves to do item or persists it, right? So usually what you hear is you do a range, act, assert, right? You got your 3 bits and bobs where you want to put your things, your slots into. So anybody who's reading the test can basically open the test up and they can see where you're arranging, where you're doing, and where you're asserting, right? So it's a very familiar pattern. Any programmer should be able to look at a test and instantly know how to read it. Okay. Now, the problem that I found with what I've been doing in the past when I was trying to learn it is I have some functionality here, and this is mostly how I did it, maybe like up until a year later, until I had like a bit of a realization of what a unit test suite actually is what I would do is like, okay, I mean, what is this doing, right? So, well, it's adding the thing, it pops a little counter, and I mean, we already defined what we want to test, right? So it's kind of a use case. You call add, it's going to add it to this list. Let's go ahead and test it that it actually does it. I mean, we can read this and we can see that it does it, but imagine that it could be a little bit more complex than that. So anyway, let's try to fit it into this model. So we're taking some code here and we are trying to run it here. What are we going to need? We're going to need a list. We're going to have a new to do list, not tests, just the actual list. Let's import this, right? So we got our list. Cool. To our list, we will then go ahead and add, right? Add, just like that. And we'll just add a new to do item, right? Where we're going to have some test content, right? All good. So we created a to-do list, we add to it, and now how do we assert it, right? So what you don't want to do is you don't want to make your privates public for the sake of testing, okay? So this could be part of like writing code that is easier to test. If you have a lot of private methods in your class, you probably have a class that is doing a single thing hiding in there. So then you want to take that out and actually have that unit testable as well. Do not expose privates as publics just for the sake of unit testing. In this case, it's very simple. To test this, we can go ahead and use this all function that I've written here. Okay, so if you have something private, do not expose it. If there's a lot of functionality hidden behind your private function, it is probably time to take it out in a different class and just have separate unit tests for that, okay? This private itself, we don't really need to test it. We test it indirectly. It exists there to sort of fulfill the function of this add. So we do not need to test this, okay? What we're doing is we are testing that this does appropriate things, and we're gonna do that by testing this function as well. So we're like doing it indirectly. So list all, and we want to make sure that we're asserting here, right? So we're gonna assert a single one out of here, okay? And we're gonna have this is going to be a saved item, right? I mean, it's still a to-do item. Just think maybe a little bit better to call it saved. We can then assert that it equals, let's say, the content of the item is going to be this test content that we've written, right? And it's highlighted there that it could be null, so let's go ahead and say not null. Saved item. Cool. I'm gonna go ahead and run all my tests, so that's gonna be Control T, Control A keybind, or I can right click and kind of run it, okay? And or Control T, Control R to run this specific test. But there you go. I run all the tests, that passes. Woohoo! I know my application works. I mean, I knew that before as well. This was one approach where we have our application here, and then we are trying to fit it into this model. That is not too bad. What I am urging you to do, or what I want you to think about, you're not taking your application and putting it into unit tests, right? That's not what's happening. Your unit test is a client, just like your web API, you know, the JavaScript HTML client you write to make a call to your controller, and that returns data. You're doing the exact same thing. This is just another client. The way that you interact with .NET through the command line is the interface where you type in commands and then stuff happens. This is your test suite is the exact same thing. Okay, you are writing an application that interacts with your application. You're essentially writing usage scripts of your application. Okay, I found personally acquiring this sort of thinking where, okay, I'm no longer trying to cram this functionality into some sort of defined box here that some expert came up with. I'm writing an application that is running interacting with my other application the way that I intended to interact with it, okay? And then if I have some kind of use case or an edge case, I can, write a test for it. So let's go ahead and do this maybe slightly a little bit different or slightly differently. Let's say that the to-do item ID increments every time we save, every time we add, okay? So in this example, we're not going to think about, we can still have the same structure, although the thought pattern now is we're not picking out the things that we're from here to stick into here. Here we are using our unit. We are using it like as if you would be using it in your real application, as if you're trying to simulate a call that you're going to do to an API that is eventually going to end up here, right? Instead of having your browser as the client that you interact with, you have your unit test as the thing that you interact with, that you use to interact with your application. So same as before, we do a to-do list, and let's go ahead and in the act, we can even copy the thing from here and put it here twice. Test 1, test 2. We can then go ahead into the list, and we're gonna expect that all of our items, there are gonna be 2 items in here. So let's go ahead and just to array this, I think that will be okay. So this is going to be items, and assert that equals 1 will be for items in the first position for the ID that we got there, and it's going to be 2 for the second position, okay? And we can also test the count, but generally just running the tests again should be no problem, okay? So hopefully you understand the difference. You are not trying to take your application and fit it into this form. What you're trying to do is you just have your thing, or a way, you're describing a way that you're interacting, right? You're scripting a way to interact with your application, and that's what a test is. Because you're at the end, when you're asserting, you're essentially verifying that that interaction has been, as you expect. This is how you intend to use the application. This is your interface with which you interact with your application. Although at the moment you interact on a unit level, later on the system-wide test you interact with the whole system. Hopefully that makes it a little bit more clearer. And let's go ahead and write our final one. I mean, it's not too crazy. This application is not too hard, right? We're gonna need the to-do list anyway. This time what we want to do is complete sets to do item complete flag to true. Okay, I have some other functionality in there. There's clearly a bug, and we're just gonna sort that out in a second. So let's go ahead and arrange. At this point, we might consider the addition operation of our to do item as an act, but that's, however, an assert. So let's go ahead and add a item here, and we're gonna know that it's ID of 1. So the end here, we can go ahead and say complete of 1, because I mean we're just interacting with our application. This is how it would be used. This is its behavior. If that's not how it behaves, we go and change it so it does behave like that. Okay, and this is where sometimes it's useful to have in tests like these that you're not only testing a content that you provide here, but some other side effects of the functionality, like having the ID set. So for example here, we will go ahead and test the ID as well. All right, and then run that test. So they're all gonna pass, but this one's still haven't been finished writing, right? But it's, you've seen that was more of a reflex, that I've changed the test and I just ran them all again, just because that's how it happens, right? And that's the way that you're going to be doing it as well. Once you get in the groove of it, like you are writing another application that is using your application. And we're going to take a look at what you can do to prevent rewriting your whole application to use your application, when you change it. So we're going to see how you can change your application to not rewrite your whole other application. We do this complete, and then what we want to do is we want to still go ahead, grab all. We'll assert that it still has a single one. All right, so completed item. Well, let's go ahead, grab it. I'm gonna assert not null. All right, completed item. Assert equals. We still want it to have the ID of 1, that sort of thing, and let's assert true, and we're gonna say complete. Okay, and on here, once we create a to-do item, we can also assert complete. We'll assert that it's false, right? So when we are creating an item, it shouldn't be complete. When we are completing an item, that's when it should be complete. Okay, so let's go ahead and run that. And the last one will fail, so assert fails. You can see that the actual ID is 2, and that's because I'm incrementing the ID counter. So let's go ahead and change that. Okay, so obviously this is a very scripted way for me to show you what unit testing is. So the primary takeaway here is, one, the mindset change, that you're not taking your functionality and then you're going to try to cram it into a test. You are using the testing framework as a client to interact with your logic. Now let's take a look at how to, which things in here will be a liability. At the moment, we have a persistence layer in here, and it may not be apparent at the beginning, but this is essentially a database. At the moment, it is an in-memory one. However, let's say in the future, we are going to change this to a database. What is going to happen is this is going to go behind an interface, and then you're going to have to inject in a constructor into here, and being able to realize that something like this may represent a database, may represent some other kind of structure. It's worth basically putting it behind an interface and then going straight to mocking rather than injecting it straight into the class. This is why sometimes it is better to still put your entity framework behind an interface in a repository pattern rather than just injecting your DB context straight into functions and into separate services. Okay, so yeah, pretty much if we now refactor this to be in a database, all of these tests will have to change in order to rely on an interface that sort of behaves well, and we're going to have to use a mocking framework, right? So that's that. Let's go ahead and take a look at the next thing. Next thing is cache. So again, this is a pretty simple example, a caching situation where we have a piece of content. We are going to give it a bit of a time that it can, like an expiry time. And yeah, I mean, it's just a simple cache. Usually, I don't know if you've used caches or not, but yeah, that's a cache. So again, this time from the beginning, we're just going to go ahead and try to use the cache. Fact public void. And what I'm just going to say is that I don't like creating tests like is empty when created. I think those are fine, perfectly fine tests if you want to get your foot in the door for a thing. But in this scenario, I just want to get down to the use case, right? What is a cache supposed to do? It's meant to tell me that we've seen this item before, if we did. So let's go ahead and say caches item within time span. Let's go ahead and create our cache. This should be a new cache. Time span is going to be a little bit weird to create this, but let's go ahead and we'll just say 1 day, because I mean, I'm not stupid. I'm going to know if I put 0 in there, there's going to be a little microsecond between now and the last collected time. So I'm just going to, apply our brain. When we then go to cache, this is still part of the setup step, so we want to go ahead and add a new item where we're gonna have some kind of URL. Okay, so this is a new URL. it will have some kind of content, and let's go ahead and say date time now, and then let's go ahead and act. So cache contains, and we'll check the URL that we've just added. So here's where we're acting. So contains, and now we want to assert, right? Say true, contains. Okay, let's go ahead and run this test. Whoa, something's wrong, right? So, I mean, usually, well, what could be wrong? We clearly should have this URL in here, so it should go into here. So this is where sometimes you think you're doing the right thing, but really not. And this is part of the things that I try to test when I test my logic. Is when I have something like this, I have a very hard time arranging it in my head what is actually going on, right? Because we have the cache time, and this is the amount of time that is allowed for the cache to be present. And this thing right here, because we didn't name it, it's a little bit hard to tell, but time right now subtract from when we last collected. So if this is the instance, this is going to be 0, and it's not going to be really be bigger. So sometimes when I have this whole mathematic thing going on in my head, I just, I can barely tell left from right when like you ask me on the spot. I'm like, oh man, I have to look at my hands and I'm gonna be like, okay, which one's left, which one's right. I get confused with if statements as well. So as much as I know about abstraction, design patterns, and how to actually solve problems and applications, I still struggle with if statements and ternary operators and stuff like that. Obviously, extracting this into a variable helps, but this is where, again, unit testing, no matter how smart you think you are, can come and save you for the simplest things. So let's go ahead and run this. And now we're good. Now we know it's working. Cool. Let's go ahead and make sure that our time cache busting actually works as expected. So let's say that we would not caches, but rather busts item within or outside time span. Okay, so here I'm just gonna go ahead and subtract 2 days because we have collected it 2 days ago. All right, let's go ahead and run this, and don't think that's gonna be, sorry, add days -2, right? So we add -2 days. The subtract was for a time span. Okay, and we have an assertion failure, and this is just because copy pasta and you sometimes just forget, but this is where having fast tests pays off. So there we go. I'm more or less confident that's how it works. Let's go ahead and also make sure that we get false when cache doesn't contain item. So let's say busts. I mean, cache busting is not really the correct term, so let's say contains returns false when doesn't contain item. I mean, sounds silly, but I mean, let's go ahead and use it, right? So let's say I mean, this bit doesn't really matter, or we don't really need to set that item up there. So we'll just say does contain the URL, and should return false, right? And same. So let's say somewhere here it contains returned false when outside time span. Okay, so generally this is the process. You're going to write a little bit of test, you're going to refactor it, and you're just taking a look at how it's using your unit. Okay, and again, same as with the example with the list where it's kind of representing a database. This is the same thing happening here, right? So we got two things. As a service that's being injected, if you think about how it's going to be used in the dependency injection, having the time span passed in the constructor can be a little bit of and basically changing this will break all of these tests, and you're going to need to write some kind of infrastructure. So having some kind of factory, some kind of service that is going to determine how much an item can be cached for can live here, or because it's a more abstract, more generic process. Like if you watch my video on generics, if you have items of a particular category and each item has kind of their own configuration, for how much it should be cached for. Maybe we inject a service which then takes an item and then determines how much it should be cached for. We mock that service, but that service itself, when we unit test, that doesn't need any mocking because, I mean, it does the calculation based on the item, or it maybe has a little bit of concretion, or it looks in the database and it checks the configuration in the database, okay? But again, we just use our tests to write an application that is using our units, okay? But yeah, some kind of factory to determine a time span cache, because if we change this bit, this is really the only bit that will change. And as well, this cache, let's say we want Redis, we want another box that we're gonna communicate with via HTTP WebSockets, whatever, right? This is another situation where this should be really some kind of service that gets injected. And seeing these really hard dependencies, it's something you just see over time. So if you notice your tests break a lot, try to see what is the exact thing that you're having to change. And the next example hopefully can highlight another way where you're writing your tests and for some reason it just breaks, right? So let's go ahead and take a look at property hash. Here we have a couple of things. So let's go ahead and create a hash tests, right? Go ahead, put this here, and let's take a look. So here I have, because it's a little bit of a bigger test, I have two things here. Property hash, and this is a way that I'm just going to say we have some kind of item and we want to hash it based on its content. So I'm going to reuse the content from the cache. Let's go ahead and say public void. And really the usability of this is I wanted to give it some kind of type and then have some kind of selectors of properties of that type to convert them to strings, and then just concatenate the strings, and that will be the hash, right? So I'm just taking things one by one and concatenating them and producing a unique hash out of those fields. So that is really the thing. So I mean property hash, say put it like this, and obviously write the rest of the name of what we're going to do. Concatenates selected fields in order. Let's go ahead and create our new property hash. Just put it like this, import it. Nothing's in here. We then got a hasher. We're gonna hash something. We're gonna need an item. So let's go ahead and grab an item from cache. Just gonna say something cool like URL. I know I'm kind of reusing dependent, whatever, you know, it's a model in your code base. They timed it now. So let's go ahead and we'll say item, and we'll say some content here. And let's just say that I'll grab the item and that I want to hash its URL. Okay, and then let's take the hash. We're going to assert that the hash is indeed equal to URL. Okay, so hash there. And let's take a look at that. Okay, so now, I mean, writing a second test to kind of give another one of these to make sure it concatenates selected fields. I can use theory inline data. I recommend you set up that example. I'm just going to go ahead and change my test here to make sure that it will just concatenate them and I will get my expected results. Okay. Yeah. What you just saw there is an example of being lazy. I'm doing it in the interests of time. In reality, I wouldn't actually do something like that. Here is where you can receive a request from the business that we need to hash a different way. And if you're doing TDD, you know, you might struggle a little bit to properly do TDD, but let's say you need to use some kind of algorithm to hash your thing. So you can rebuild this, and any test that you've built for this thing, they're gonna fall over because you're gonna stick this thing in there. So how about we preserve the class and we reuse it in another class? Okay, so I'm extending from property hash and I'm overriding the hash function, and I'm just saying that, okay, let's inject the algorithm into here. And basically, because this is such a pure thing, usually if you find yourselves having to change functions and having to test to change tests for those functions, is your functionality is not generic enough. Okay, you don't have a well-defined process that you're testing, so maybe you need to think about your solution a little bit better. Okay, so if you're having to rewrite your tests a lot, that is just a symptom of maybe having not a well-defined process. So just try to apply your brain there to solve that problem. So anyway, algorithm property hash. Let's see. I would like to see Bob Martin do this one, because I mean I couldn't beforehand know the hash that it is going to generate. So I'm just gonna go ahead and show you what I kind of do. So algorithm property hash applies hashing algorithm to seed, right? Seed, whatever, reuse the function, take a different different approach. Let's go ahead and apply this here. We're gonna use what's called algorithm property hash SHA-256 pushka. So we got the hasher. Let's go ahead, use hasher. Gonna hash. Gonna have the same clause here, really. Go ahead, grab this, put it here. And we're gonna assert, this is equal. I'm gonna put something random here because I have no clue what the hash is gonna turn out to be like. So we're gonna put this here. We're gonna run the tests and we're gonna see one fail. And generally this would be my gauge for this thing being identical all the time. Maybe something like this isn't quite alright. You can see I can't fit it here. Maybe because I shouldn't have decoded it to that. So, you know, maybe my solution wasn't quite perfect. So maybe what I want to do here is convert to base 64 string, maybe hash bytes. Something like this, right? Let's go ahead and run this again. There we go, definitely the right thing to press. Okay, you know, something a little bit more readable. I can see a couple of dots flying off the handle there. So what I'm gonna do is I'm gonna put a breakpoint here, because I don't know what this algorithm produces. So the SHA-256 one for this one. So I'm just gonna hope that it's a constant one all the time. So I'm gonna click Control debug here. Okay, see the hash. Let's go ahead and view it. We're gonna copy it, put it here, stop the application, and then we can go ahead and run all the tests, remove the breakpoint. And that's kind of how this can work as well. Not all solutions can be solved with TDD, kind of like this one, where really it can be, because what we're doing is we're supplying an algorithm rather than an interface that could resolve a hash algorithm, or that can take that parameter which we pass the seed into, because then really testing this algorithm property hash, or just making sure that this hash is going to keep generating the same hash, I guess. That would be primarily what we're doing. But if we keep running the test over and over again, it keeps generating the same hash for us, and we're good here. But again, just another thing to kind of point out again. Let me just minimize this and I'll close this. In this primary example, we're not rewriting the hash function. We are, all the tests that are aiming at this, we're keeping them. We're creating another class extending this. So, you know, we do not necessarily need to rewrite the whole code base to stop pointing at this function and start using the new one for the things that require the new function. We create it, we'll leave the old one alone. Tests still work. We no longer need to retest, you know, the thing that we're inheriting, because this is already tested. We're just overriding it. And then I'm injecting a string here. Really, a better solution would be to inject a service that will consume the string, because then that service can be reused to be used with maybe not just this seed, rather some other string combination in other places. At the moment, this service is tightly bound to the creation of the hash algorithm here, and this is how you create this strong link that later if you want to take out this service into a separate service, if you haven't done that from the get-go, that is when you're gonna have to go and rewrite the test that you've just written. Okay, but this was just the basics. There are gonna be a couple of more episodes where we're gonna dig into a little bit more of XUnit and mocking. Hopefully you found this a good introduction. You haven't been too much disappointed by me just using facts. Haven't done any theories or class fixtures or collection fixtures. We're going to take a look at that when we're taking a look at integration and maybe system tests as well. Nevertheless, thank you very much for watching. If you enjoyed it, leave a like, subscribe. If you have any questions, leave them in the comments section or on my Discord server. I stream on Wednesdays and Sundays. Link to my Twitch is in the description. So come follow, join up. And as always, I hope to see you in my other videos.